Hello everyone, welcome to Circuits and Network class. Today we are just going to deal with some of the important equations that you need to know in the fifth module. And we are going to first deal with some of the equations related to the interconnection of two-port networks. Now over here we have three types of connection. You have the cascade connection, you have the parallel connection, and you have the series connection. Okay, so if you see any of the networks in any of these particular formats, then you can uh, find out the parameters by using simple relationships instead of carrying out the whole analysis in one particular step itself. Okay, so it is mostly easier if you can identify the networks, whether they are cascade, parallel, or series. Okay, now moving on to the cascade connection. In the cascade connection, you are having one network, and then the next network will be coming right after the previous network. And the cascade connection is possible. You can find out an easy method to find out the ABCD parameters or the transmission parameters of cascade networks. The relationship is that you can find out the ABCD parameter of the network 1, and then you can find out the ABCD parameter of the network 2. You multiply these two parameters and you will be getting the ABCD parameters of the whole network. Okay, and the derivation is quite simple. I'm not going to discuss the derivation in detail over here, but you should go through the details. It will be asked for the university exams. It is a commonly asked question. The derivation is simple. You first write down the ABCD parameters of the network 1, then you find out the ABCD parameters of the network 2. You replace the voltages and finally you will be getting it on solving. Okay, and similarly you just check out the parallel connection. In the parallel connection you are having two networks, and these two networks are connected in parallel. So when they are in parallel, what is the specialty? If they are connected in parallel, the current gets split, but the voltage remains the same. That is, the voltage for both of the networks are V1 and V2. But the current is being split into two. So you are going to just represent the split current as I1 dash and I1 double dash. And on the second port, you are going to represent it as I2 dash and I2 double dash. Okay, so you have two currents. The incoming current I1 and I2 are getting split into I1 dash, I1 double dash, and I2 dash and I2 double dash. Okay, and this parallel connection you can relate it with your Y parameters. So what you can do is you can find out the Y parameter of the first network, you find out the Y parameter of the second network, and then you can see over here that this total current is being split into two networks. So network 1 current is I1 dash and network 2 current is I1 double dash. So you just add the two currents of the two networks and you will get the total current, and similarly you can get this particular derivation. And similarly for the series network, it will be you add both the Z parameters. You just add both the Z parameters. Over here you can see that the current is the same. For series connection, always the current is the same, but the voltage is getting split. Now, when it comes to problems, okay, I will just go through one problem. I'm not going to solve it. You have a particular question, that is, you have two networks over here. Okay, you have two networks over here. One network is 1 ohm and 2 ohm, and the other network you have like this. Okay, this is your other network. Okay, now it is told in the question that both of these are connected in series. Okay, both of the networks are connected in series, and for the series connection you have to find out the Z parameters. That is the combined Z parameter when these two are connected in series. So what do? You have to find out the Z parameter of this particular network, and then you find out the Z parameter of this particular network, and then you simply add the Z parameters. Suppose you had to do it by first connecting the two in series and then finding out the whole Z parameter. It will get complicated because the circuit is getting bigger. It is easier to find out the Z parameter when the circuit is smaller. Any of the parameters, whichever parameter it is always easier to find the parameters of smaller networks. When it is a combined network, the network becomes complicated and it becomes difficult to find out the parameters. That is why we have found out such relationships. So please note, for the cascade connection, it will be the multiplication of the ABCD parameters. For parallel connection, it is the summation of the Y parameters. And for series connection, it is the summation of the Z parameters. Next, let's move on to the T network transformation and the pi network transformation. Okay, if you want to convert any of the particular network into a T network, if you want to convert any particular network into a T network, you can use it by using these equations. You can use these equations for the Z parameter, and you can convert your particular network into a T network. And this is the figure for the T network, ZA, ZB and ZC. And you have the equations over here. So if any question is asked, if they have given a particular circuit and asked to find out the T network of the particular network, then all you have to do is find out the Z parameters of the network and then use this equation. Find out the Z parameters and use this equation. You will get ZA, ZB, ZC. Draw the figure. Similarly, for pi network transformation, you find out the Y parameters of the particular network and then you simply use the equations given over here. Okay, so you have to study the equations in detail. The last topic that I am going to discuss in this module is the interrelationship between parameters of two ports. Okay, interrelationship between parameters of two ports. That means how can you convert a particular parameter into another parameter. So I will just show one particular example. Okay, you can do the remaining on your own. It is not necessary that you have to by heart the equations because you have a lot of equations to study. Okay, you can find out the Z parameter in terms of Y, ABCD and H parameters. Similarly, the Y parameter you can find it in terms of Z, ABCD and H. Similarly, you will be having all the parameters can be converted into the other parameter. Okay, so there will be a lot of relationship, that is you will be having approximately 12 relationships, and it is not easy to study all of these equations. So you can just know how to convert one parameter into another parameter. Now all the parameters, they will be having the voltages V1 and V2. They will also be having the currents I1 and I2. Okay, all the parameters, irrespective of which parameter it is, the Z parameter, Y parameter, ABCD or H parameter, all the parameters will be having these four terms, that is V1, I1, V2 and I2. So all you have to do is rearrange these parameters. Now I want the Z parameter in terms of the Y parameter. Okay, I want to convert my Z parameter into the Y parameter. So what am I going to do? I want to convert this into this form. So what am I going to do? Here you can see it is I1 equal to I2 equal to. So from these equations, I will just give it an equation 1 and equation 2. From these equations, I will try to convert it into this form. I1 equal to and I2 equal to, and there should be only V1 and V2 on the other side. So I will just take the first equation and I will write it as I1 equal to. Okay, if you write it as I1 equal to, you will get V1 minus Z12 I2 divided by Z11. Right, it's correct, right? So I will just give this as equation A and I will substitute equation A in the second equation. I will substitute A in equation 2. So what will you get? You will get V2 is equal to Z21 V1 by Z11 minus Z21 Z12 I2 by Z11 plus Z22 I2. Okay. So I have got I1 equal to, and I substituted that value in the second equation. Now you can see over here I have V2, V1, I2, I2, both are I2. So I can get this particular equation after the substitution. So I can write I2 equal to. I2 equal to. How can I write I2 equal to? So first I'll just take I will take the LCM over here. Okay, so let me just take the eraser so I can make some space over here. So I will just take the LCM over here. So I will get V2 is equal to Z21 V1 by Z11 minus Z21, or I'll write like this, minus Z21 Z12 plus Z11 Z22 into I2 divided by Z11. Now I will write I2 equal to. So you will get I2 is equal to V2 minus Z21 by Z11 V1 whole divided by Z11 Z22 minus Z21 Z12 divided by Z1. Again I'll just take the LCM on this side over here. So you'll get Z11 V2 minus Z21 V1 whole divided by Z11 Z22 minus Z21 Z12. divided by Z11. This Z11 and Z11 gets cancelled, and I will write it as Z11 divided by Z11 Z22 minus Z21 Z2 Z12 into V2 minus Z21 V1 divided by Z11 Z22 minus Z21 Z12. Okay, right. So you have got, oh, I am really sorry. Actually, when we started doing this, you got the Y parameter in terms of the Z parameter. Okay, this is actually the other way around. You got the Y parameter in terms of the Z parameter, because now you have got the Y parameter. You can see this is the Y parameter, right? I2 is equal to a term, that is Y21 into Y22. So from by comparing this equation, I will just name this as equation 3 and equation 4. By comparing the equations, you will get Y21 is equal to Z11 by Z11 Z22 minus Z21 Z12, and you will get Y22 is equal to, and you will get Y22 is equal to, right, actually here it is V2, so this will be Y22 and this will be Y21. Okay, you should check the coefficients also. Okay, you should also check the coefficients. Right, the coefficient of V1 is Y21. So here the coefficient of V1 is over here. So this is Y21 minus Z21 by Z11 Z22 minus Z21 Z12. And you have Y22 is equal to Z11 by this. So you can just write this denominator as delta Z. That is easier. Delta Z minus Z21 by delta Z. Similarly, you can find out I1 equal to, you substitute the value of I2. You have already got the value of I2. You substitute the value of I2 over here in your equation A, and you will get the equation for I1. So here actually you are finding out the Y parameter in terms of the Z parameter. Okay, if you do the other way around, you will get Z parameter in terms of Y parameter. That is, you should change the Y parameter equations. Okay, so if you want as an easy method, the one which you have to change, Z in terms of Y. Okay, if you want Z in terms of Y, you always take the Y parameter equation and start changing it. Then you will get the required. See, here you got a Y parameter. Okay, here you got Y parameter in terms of Z parameter. So in terms of Z parameter means if you want it in terms of Z parameter, you should start changing the equation of the Z parameter. You just take it in that particular manner and you will get all the derivations. Okay, I hope what I mentioned was clear. If you want Y parameter, suppose I'll just explain it again. You want the Y parameter in terms of your ABCD parameter. In that case, you should start changing your ABCD parameter. You start writing your ABCD equations, that is V1 is equal to A V1 minus B V2, sorry I2, A V2 minus B I2, and I1 is equal to C V2 minus D I2. Now you start rearranging this in the form of your Y parameter, and then you will get Y parameter in terms of the ABCD parameters. Okay, so whatever is written on the second side, in terms of which parameter you want, that one you start rearranging and you will get the required other parameter. Okay, so I hope the video was useful. We have discussed some equations and how to find out one parameter in terms of the other parameters. Stay tuned for more videos. Thank you.